Okay, for our battery activity, we're going to go over how to inspect the battery, some of the things we need to be looking for when we're doing an inspection of an electrical system, some of the things to watch out for. We will go over the procedure on how to clean our terminals and our posts, make sure we have a really good connection there, and we'll show you some of the hazards and tools that we need to use when it comes to servicing batteries and the proper procedure in doing that. Okay, to start it off, we're going to go over some of the tools that we're going to use when we service batteries, and also some of the safety components that are necessary to protect ourselves. First things first, safety glasses. We should always have those. Absolutely important when working around batteries. We do have that sulfuric acid mixture. We need to keep our eyes safe. Gloves are absolutely necessary to protect our hands from that mixture as well. Any corrosion that we'll be cleaning, we want to keep it away from our skin. Speaking of the corrosion, this is baking soda, which we will use combined with water. Neutralize any corrosion first, and then we can clean it off. Next up, here's our battery maintenance toolkit. Several different tools in here that all have very specific jobs. First things first, this is a battery terminal puller. So if we have battery terminals that are stuck in place, that are hard to get free, we can get this over the terminal, screw down the stamp, and it'll pop that guy free. Next thing up, we have battery terminal spreaders. So if we need to make our terminals a little wider to go around a bigger post, these will help spread that out, also correct the shape if something has happened to that battery terminal. These are battery terminal pliers. They're just offset at an angle to make it nice and easy for you to get in there and work around those tight spots. These are great when it comes to loosening the terminals and removing them. Finally, we get to the cleaning tools. This is a side post cleaner. If your vehicle is equipped with a side post battery, this will get down in there and clean those threads out, any corrosion, and clean that up. This is a scrub brush as well for our side posts. This is our scraper tool that we're going to demonstrate in a little bit. This is used to clean both the battery posts. You can see it has the positive and the negative, and the battery terminal itself. So this will help clean the corrosion off of that and give us a nice new metal on metal connection between the post and the terminal. Alright, the first thing we're going to do is inspect the battery. There's several things we want to look for here. First of all, loose connections, frayed wires, any kind of bad connection. We want to make sure all these are solid, that the battery terminals themselves aren't loose on the posts. Right here we have a loose bolt, and that could create starting or charging problems. So check your connections first. We also want to look for any corrosion that's present. We do have some corrosion kind of over here and around our battery bracket. A little bit is okay, but if there's lots of gunk on a terminal, then we could have some other problems present, like an overcharging issue or undercharging, but there could be some deeper electrical problems that we're going to have to check for. We want to make sure that the hold down bracket right here is tight, that this battery cannot move. They are very sensitive to vibration, and we can't have them jumping around in here and sliding all over the place. So make sure these are nice and tight, which looks okay. We also want to inspect the battery itself, make sure the case isn't cracked, it's not leaking anywhere, that your vent caps are present. But it's pretty straightforward, just a general visual inspection of the physical connections and physical state of the battery. Something to keep in mind on modern vehicles when disconnecting batteries and removing them is sometimes we need to supply temporary power to the car, so we don't lose memory stored in computers or other programmed functions in the vehicle. One of the ways we can do that is through these two different adapters. These will connect to the auxiliary port in our jump pack, and then either through the OBD2 connector on your car or the accessory port, cigarette lighter. And then we can power it up and supply 12 volts out this connector to at least keep those memories stored in the computers and hold those settings for the vehicle. Okay, to install our auxiliary power cable, first I'm going to plug in the OBD2 side. our battery is still connected. We have not disconnected our ground yet. I'm going to check the OBD2 plug first by plugging it in. It is not plugged into the jump pack yet. Plug that in over here, and I can see a red light down here telling me that this connection is good. So we know our OBD2 connector is functioning. Next, I'm going to power up the jump pack. I want to plug it in on this side and make sure our jump pack has power and is supplying electrical power. I can go and plug this OBD2 connector back in. Just like that. And now when I disconnect my ground cable, this vehicle will still have a power source. Okay, since I do have some corrosion present, we've mixed up some baking soda and water. And we're just going to squirt that on the terminals. Anywhere where you see the white acid material, you can hear that baking soda go to work in neutralizing that acid. Okay, if there's a lot present, we can scrub it off and remove it. Get it out from underneath the bracket, around your terminals. We're going to clean these a lot better in a minute, but for now, we just want to get that corrosion off the battery. Okay, now we're going to go ahead and remove the battery terminals. You would do this to clean the terminal in the post if there was corrosion, maybe preventing the battery or the car from starting. We would also do this if we had to replace the battery. We would follow the same procedure to disconnect the clamps. So the first thing that we're always going to disconnect first is our ground cable, our negative. And we can tell that a couple different ways. First of all, it always usually goes to the body, the frame, or the chassis of the vehicle. And that's one way to make 100% identify that this is the ground negative cable. You can see it branches off right here and is bolted straight to the metal part of the vehicle. There is a negative symbol on the battery right underneath the clamp here. But sometimes, especially today with how big battery terminals are getting, those aren't always viewable when the terminals are on the battery. So there's a positive over here, which you might be able to see right there. Okay, so we've got our terminals identified. Now we know which one we can remove first, or that we need to remove first, I should say. That's going to be our negative. When removing terminals or working around batteries, we want to be especially sure we don't get any metal objects between the two posts. That's why working with small stubby wrenches is a great idea when you're working around batteries. It just minimizes the hazard of accidentally getting a tool between those posts. So I'm just going to loosen the terminal nut. We don't need to fully take it off, at which point the battery clamp should get loose and usually come right off, like so. Now that I've removed the negative terminal, I can position that out of the way. The system is now de-energized. There is no electrical energy that is available to the vehicle. It also makes it a lot safer to work on the positive terminal now. We don't run the risk of short-circuiting by touching anything metal because the ground cable has been removed. So that's why we always remove the negative cable first. I can then move to our positive cable and remove that, which should be enough to get our terminal off of the post. We're going to want to get the terminals away from the battery. They're going to want to go back to where they were, and we don't want these terminals reconnecting on their own. So position them out of the way, insulate them if you need to, so that we don't have any accidental reconnections. The hold down bracket is secured in two places. On this side we've got a bolt, and over here we've got a rod that goes down with a hook. So again, we just need to loosen this a little bit so we can get that hook and twist it out of the way, and we'll be able to pull this bracket right out of here. So the theme with batteries is don't fully unscrew things. Just loosen them, and then we can remove them. So it's a little bit of a game, but you can see our hook rod here that was latched underneath the battery tray. I loosened this nut on top just a little bit. That allows the hook to drop down, twist it out of the way, and remove our bracket. Alright, now that we have the battery out of the vehicle, there is some things that we can talk about when it comes to our battery label and just good battery habits. We want to keep batteries off of cold concrete floors or metal tables. If you leave them directly on the ground, it can cause the battery to discharge over time because the bottom half of the battery or the bottom part of the battery is colder than room temperature. So always get them on a piece of wood or rubber mat. Plastic battery tubs are great, but something to insulate that battery. Battery label, a lot of important pieces of information that we get off of this when it comes to replacing your battery. Our group size 24F, that is the physical dimensions of the battery. How big is this box and where are the posts located, how are they arranged? So when it comes to replacing your battery, that's what that number represents. Another specification we're always looking for is our CCA number. So you can see right here, CCA at 0 degrees Fahrenheit. This has a CCA rating of 600 amps. That is the capacity of the battery, or how much current this battery could deliver over 30 seconds at 0 degrees Fahrenheit. So that is kind of how much power does this battery have. Another number that's over here, we have RC minutes, which stands for reserve capacity in minutes, and that is how long can this battery run without being recharged. So with these two numbers, we can kind of tell how powerful is the battery and how much capacity does it have. Okay, to clean our battery posts, we're going to use the scraper style part of our tool, and the posts are different sizes. Okay, the positive post is larger diameter than our negative, so make sure you use the right end of the tool. This one has a big plus on it for our positive post. You're going to get that scraper down all the way over our post. Then we're going to run it around. And you can see it kind of chews just a new layer of lead off of there. So we've got a brand new clean connection on our post side. And flip it over to our negative. I'm going to do the same thing over here. And we've got some bare metal. Make sure we don't, careful, these little burrs will be sharp. Don't grab them with your fingers. But the tool should do most of the cutting for you. Got our battery terminals here. You can see them. Now is a good time also to clean out your battery tray. Any water that dripped down while we were neutralizing the acid. A lot of times there's dirt, rocks, and debris in there we don't want our battery sitting on top of. So a little housekeeping. This time we're going to use the male end of our tool. You can see our scraper tool right here that we're going to place inside our battery terminal from the bottom to the top. And just cut a layer of that terminal out. Okay, nice and shiny. I'm going to come over here and do the same thing for my ground cable. It is a taper, so just push it in as far as it will go. Try not to put tension on the connections themselves. We don't want to cause any stress on the wire of the terminals. We just want to get them clean. That's looking pretty good. Okay, terminals are cleaned. We'll show you how to check the battery voltage with a multimeter. We're going to go to DC volts, which is the V with our straight and dotted line. And then I can take my red and black lead and I'll put the red on positive and the black lead on negative. Let's see what our battery voltage is. 12.1. So this battery is significantly drained right now. 12.6 volts would be a fully charged battery, and as soon as we get to 12.0 and under, 11.9 volts, we consider that battery 0% charge. So we want to take this over and put it on a battery charger, get it back up to 12.6 before we put it back in the vehicle. Next, we'll show you how to test our battery to see if it needs to be replaced. How much of its original capacity can this battery still supply? In the past, we would use load testers to do this, where we actually extracted an electrical load from the battery to see what it could do. Modern vehicles, we've kind of gone away from that, and we use conductance testers, which just send a signal in the battery and kind of explore the battery and determine its capacity without putting that big demand on the battery itself. I'm going to go ahead and get my cables connected. This tool happens to have a wireless pod, so it's going to power itself up off the battery itself. Alright, I'm going to go down to battery. These also usually have a multimeter option, so if we wanted to check our battery voltage, we can do that right here as well. 12.05. I'm going to go down to battery, follow the pictures. This is an automotive battery. We are out of the vehicle. It's a 12-volt battery. And this is a regular lead acid battery, not an AGM battery. AGM spiral would be our Optima batteries. So we just need to tell the tester what type of battery we're dealing with. We are going to put our capacity in by CCA, which we looked at just a moment ago. And our battery is 600 CCA. I tell the tester how big the battery is. We are above 32 degrees. And it's going to run its test. Tells us our battery is good. We need to recharge it, but it would still be able to start the vehicle. And this is one of the other benefits of our conductance testers, is we can test batteries that aren't fully charged, whereas if we were using that load tester, we would have to get this battery all the way back up to 100% before we could even run tests on it. So go ahead and back out of that. Drop our battery into place carefully. Okay, we're fully in our battery tray. Keep the terminals away for now. We're going to go reverse of removal, so we'll put our hold down clamp back in place. Okay, we're going to go ahead and reconnect our terminals. And we're going to do that in the reverse order that we disconnected them. So we're going to put our positive clamp on first, and always put our ground or negative clamp on last. Okay, nice firm connection. We want as much contact as possible between the terminal clamp and our battery post. Okay, we're going to go ahead and tighten our positive clamp. Not too much. Don't want to break it. Just enough that it's secure and not going to move. Positive clamps in place. We can go ahead and connect our ground clamp. We want to make this quick and a nice connection. We will get a little spark between our ground post and our terminal clamp, so we don't want it repeatedly touching. So quick, get it on. Now we can tighten this one down. terminals are tight. Okay, if you're having issues with your battery going dead when the vehicle is off, you might have what's called parasitic drain, where the vehicle is drawing power off the battery even though the keys are out of the ignition and the car is off. There is a test we can do with a multimeter where we can see how much current the vehicle is drawing when the keys are out of the ignition and in the off position. To do that test, we are going to need to remove our ground negative terminal. In order to measure current or amps, we need to get the meter in series with the circuit so that it's in line and part of the circuit. To do that, we're going to work on the ground side. It's a little safer. And we're going to make the meter the last connection to the battery. So any power going out the positive into the car and returning through the ground is going to go through the meter, and we can see what that amount of current is. Take my positive lead and I'm going to get that on my ground cable, my negative terminal. Okay, I'm going to take my negative lead and I'm going to put it on the negative battery post. We're going to let it settle out for a minute. And what we want to see is a number that's under 50 milliamps. So right now we're looking at about 35 to 46 milliamps. So we are within specification. This car should not be draining its battery. Anything over 50 milliamps or 0.050 amps, we're going to want to investigate some circuits, maybe disable some fuses and see if we can locate the source of that draw, find the component that is drawing electricity off of the battery. We got our battery reinstalled. Our hold down bracket is tight. This battery's not going anywhere. Got that loose connection tightened up. Everything is clean and tight and in the best condition that it can be. Now we can move on to checking the charging system of the vehicle, testing the alternator, and checking the starting system as well.